Another attack is called the Teardrop Attack. The Teardrop Attack is another malformed frame type of denial of service attack. What the attacker does is, again, spoofing some other source IP address. He never wants to use his own. He wants to remain anonymous. He'll use a spoofed source IP address, and he'll send the victim a frame that is identified by toggling on flags that says, I'm a fragment. I'm the first fragment. And then he'll send another frame that says, I'm the second fragment. But when he sends the second fragment frame, he identifies the wrong location where to align the second piece to the first piece. You see in the top part of that diagram, we see the first fragment and the second fragment aligned correctly. There's this code called the offset. That is, where does the second fragment align relative to the first fragment. And that's in the top diagram. That shows the appropriate alignment, how functional fragments work. With the teardrop attack, I send an incorrect offset. I say this is the second fragment and here's the offset, but the offset is incorrect. In other words, the pieces don't fit correctly. So when the recipient receives these fragments, he first receives the first fragment, says, okay, I've got more fragments coming, I have to align them. He then receives a second fragment, and it doesn't align correctly because of the incorrect offset value. It aligns in such a way that the recipient can't piece these two fragments together. And as a result, the recipient doesn't know how to process these frames or fragments, and he simply starts holding all the fragments that are incorrectly configured, and again consuming the buffer space for available inbound connections, and as a result doesn't have buffer space available for legitimate inbound connections. So this is the teardrop attack, another malformed frame providing a denial of service attack on the server.